Yeah, we're live. We're back again. I'm excited. I actually continued with work yesterday. I had to attend a concert, so I just took a little break and chilled a little bit. When I came back from the concert, I continued with what I was working on, and I actually did figure out or fix what I was working on. Turns out, if I show you, I'm not sure you're following yesterday. So I've done quite a bit of work since yesterday, but if you're following this, um, I believe what I was doing yesterday was a little bit illogical. So I was picking on this identifier. However, this actually does return a boolean, but I was trying to convert it to a string and check if it's this or that. But when you pick into it, it only tells you if it's the type of whatever is within this. They could be when you say identifier, it's mostly just kind of like any kind of identifier. You could also check a token. Like, let's say I want to check if the next stuff is a return keyword. I could do this, and it's just gonna tell me true or false. So it doesn't actually give me the. It's not like if you use something like num parser or even within this, um, when you're using the parse this and stuff, like it actually eats up the token, but this doesn't do any of that. Like if you've used speak from like iterator, so you do like pickable blah blah blah, then you pick into it, that actually does give you, it yields the next result, but it doesn't consume it, right? So instinctively I just thought this should work like the iterator, that it's going to pick into the next token stream that matches this wherever I pass into it, and then give me the result without consuming it. That was my instinct based on how iterators work, you know. But it turns out it just only tells you if it matches that, right? So I figured that out, and that actually did work. So I had something working already. But right now I'm trying to create a little bit of flexibility. So if you go to like query turbo, yeah, do I have an example usage here? Let's scroll a little bit. Yep. So currently you could, as you can see, query turbo actually just allows you to create a bunch of queries, right, without doing some gymnastic or passing transaction ID. And mind you, even though this does look like a normal Rust code, under the hood it does generate different kind of code. Like this let statement is actually a let statement from the query builder that I've built, that I've created, right? So it's like a let statement builder, right? It generates that under the hood, but it allows you to write your code naturally as though you're writing natural Rust code. And when you're writing everything within this code block, it just automatically binds. And as you can see, we get the result of the query chain, and we can run that. We can, for example, we're taking the Tor result from this, which would be, this is the first, this is the second, and this would be, I mean, from zero index, so this would be 0 1 2, then this will be 3, right? If you want the first result, all you just need to do is come here and let's say you change back to 0, and you just need to, if that returns a balance, you need to change this to balance, and now we get balance, right? But what I'm trying to do now is, and one more thing I could show you is, let's say from balance 1 we need an amount. Like you can imagine this being a deeply nested field, right? What you could actually do is you could traverse the sort of like the tree from the parent, and yeah, now this gives you amount, right? And from within this amount you could even get some method that do some other stuff, but we actually do want the amount. And mind you, this is not going to be an integer, even though that's an integer. It's, so you can think of this like a field. It's a field, but within the context of the query, from the database perspective, when this is being run within against the database, this field is evaluated into a value which is going to be uh, an integer or fraction, whatever it is in this case. So what I'm trying to achieve now is give a little bit of flexibility. So right now, Query Turbo basically allows you to create a bunch of queries without doing it manually. Otherwise, you would have to create all these statements separately, and it's going to be a little bit unergonomic. And then you have to change them manually. You have to bind all the results and do the parameterization. All those things have been taken care of for you, like to prevent SQL injection. Besides that, I want this to. So currently, if you need to write transaction, you're gonna have to use like transaction macro, and I do have that already. Then you do begin transaction blah without this, and at the end of this, you're gonna have like commit or cancel transaction, right? So what I'm essentially trying to support now, it does seem like I am supporting it already, is I want to give the ability to dynamically do this. Like, so with transaction, you would have to use a transaction macro. For block, you would have to use the block macro. And for block, okay, before I show you this, you notice that this actually does return a transaction completion now, right? That is what it returns, transaction completion. If you want to do for block, you use block macro, and the difference with block is that it has to return something. So you can return whatever you want, but you have to return an expression. And mind you, even though I'm using the normal return statement, it's actually under the hood, like it's generating a return statement builder, right? And you can see that this returns block. So this is useful if you're trying to do some complex query. Let's say you have a select or query statement, and for each of those fields or assignments, rather than putting in a primitive, let's say like age equals to 5, you can actually have like a procedural or a procedure within that assignment that does a bunch of queries against the database, some logic, if else statement, for loop, then returns. Finally, it has to return an expression. That expression could be like a basic expression like 5. It could be the result of a query. You could even do like something as complex as this. You can do times 5. Under the hood, this actually does generate a statement. Like, this looks like you're writing a normal mathematical expression, but under the hood, it's actually generating a query builder for you. It's handling that automatically, the parameterization, binding, it does that. And you can even use like all the built-in functions I've created. So you can think of things like math.seal, just a bunch of stuff. But now what I'm trying to do is I'm trying to make Query Turbo double as like query chaining. So right now it's only allows you to have like query chain, but I want you to be able to use it as a transaction and also as a block. So you sort of get the flexibility. If you want to use that for everything, you can use it, and it's possible. And I thought, like, why not? Since anyway, if you decide to use it as a transaction and you have a begin transaction and commit or cancel transaction afterwards, or you have like a return statement, like automatically it's going to dynamically create a different types, like concrete types like block, query chain, or transaction completion, right? In which case it's going to prevent all sorts of misuse, right? So I thought, like, why not support that? But if you want something semantically appropriate, more semantically appropriate, then you might want to have to use transaction if you want, or you might have to use block. But I feel like allowing Query Turbo to do all those things is a perfectly legitimate use case or implementation. You can sort of think like Git checkout, which is more like a superset that does a bunch of stuff. You can use it to check out a branch, commits, and discard stuff and stuff. And you also have like subset that are more like specific, like Git switch and what's the other one. So that's what I'm trying to achieve here. And as you can see, we have Query Turbo. Then we have transaction, query transaction, then we have query block. So we have this tree. This query block should be more specific, but query turbo is going to be more generic, right? So thus far, I actually just add a little nap before I start this stream, and let me be sure that I'm actually live. Bear with me. So what I'm trying to do essentially now is to, so what platform are you streaming on? Is this a way of making money? Well, Paul, thanks for joining in. I'm just streaming on YouTube. Basically, I did try to stream on Twitch for a little bit, but I felt like it's easier to manage YouTube because my videos stay afterwards. I might consider streaming on YouTube later, but I'm streaming on YouTube now, and the goal of this, the primary goal, isn't really to make money, but just to share what I've been working on. So I've been working on this project for about a year, and I felt like, well, I should have probably been sharing this with you guys rather than working on this in stealth mode. And that's what I'm doing. It's an open source project, and I'm planning to launch the alpha version sometime this month. And I'm working, like, this is like the around the completion of the project, right? So I'm building like a query builder, and I can share the link to you. 1 second. github.com. I probably should put it in the description. Yeah, I'm just posting my code live or something like that. So this is, you can find this here. So that's what I'm working on right now. Yeah, I just shared the code base with you. So I have like 5 open source projects I'm working on now, and this is just one of them. So you can find like 2 of them at least on GitHub right now. So this should take statement or expression, and that comes from, okay, now this creates like query turbo, and if I show you the definition, let me zoom in a little bit. What you find out is query turbo has this inner type. So I'm allowing this to be a query chain, and it could also be a block or a transaction, like I showed you guys. This was something I did outside of the stream. So essentially what we would have to do is, after parsing this, and one more thing I could also show you is the parsing implementation of query type, query turbo. So as you can see, we first check if it's likely a transaction, and the way we do that is is there a middle service layer for the query builder? What is the chain method? How many callbacks in it? So the chain method basically takes, I'm not sure what you mean by middle service layer for the query builder, but the chain method basically takes each of those queries. So under the hood, I've created a query builder or query builders for different statements, every statement you can imagine that the graph database supports, right? So what chain method does, it takes each of those queries, query builders or statement, right, and automatically undo the binding. So you don't have to manually do the variable or parameter interpolation. It does all those things for you. And this macro just makes it feel natural. It makes it feel like you're writing a pure Rust code. But under the hood, it's actually using the builder I've created. So if you want, you can actually write the builders manually. And I have a book I'm writing. It's about 300 pages now for this project, right? I'm going to be releasing the book also, the soft and the hard copy. And there you see the different methods of working with these. So these macros are just ways for you to write things in a much easier and familiar way that feels like you're writing pure Rust. And for me, I think this is like a new approach that I've come up with, because typically when you're working with transaction in other ORMs or query builders, you have to pass like transaction IDs between statements that are coordinated at runtime. But this sort of does everything at compile time and just throws everything at your database. So it feels like you're writing raw SQL, because you're not taking all those hits at runtime and just throws it at your database, and your database does everything without having to pass the transaction ID. So what I was doing is I'm checking if it's likely a transaction statement, and the way I'm doing that is checking the first three tokens within the stream, like if the first is an identifier, the second is an identifier, and also ending with the semicolon, which is like the end of the begin transaction. So you could have something like begin transaction. When we have something like this, right, this is an identifier, this is another identifier, and this is the ending token. Like that signals to us that it's likely a transaction statement, right? And we don't even have to stop there. We could actually do a bit more, which I could show you. I believe I have somewhere in transaction parsing. Let's see. Transaction. Begin transaction statement. I'm parsing it there. Query transaction. Let's see. I'm pretty sure I did a more robust check of that somewhere that I just showed. Okay, we have it here. So this is probably something I should use there also. So I'll probably just copy these. As you can see, this checks the first three tokens within the stream and then sees if the first set of the two is actually begin transaction or if it's commit. So this is a way for it to tell, right? But what I'm doing within the query chain is right here, I want this part to only take the statement or the expression. So for example, if you have this is a statement because it's being bound to a variable, right? And you cannot assign it to another variable. But this is an expression. And the reason I created is I want you to be able to create a statement without having to bind it. So you don't have to necessarily do this, right? So I have to check if this is a statement, or in this case, it's just a mere expression, right? And that's why I'm doing that. So all these parts, doing all these checks, are basically excluding different kinds of lines. So it's excluding a begin transaction like token, custom token, or commit transaction or cancel transaction. And also if it's a return statement, it's excluding it because we only want to push statement within this, right? And that's why I'm doing that here. So if we go to where we're doing is likely, it's likely transaction statement. If we actually want to make this a bit more robust, we can use this, and we don't need commit because we are only checking if it's a begin transaction statement. So let's yep, so it's likely transaction statement. We take that, we put this here, we map that. Okay, then we have to, it's actually good we're doing this because you know what, we need to use the closure here like a function, and the reason is maybe not here, but especially when you're having your while loops, we don't want a stale result. So let's just pass the input here. And so this, what this does is quite similar to what I had earlier, and actually this should maybe be, it's likely begin transaction statement, right? So it checks the string itself, split it by white space. I could use a normal parser here, but so what is the best way to filter out keywords using macro header file? I'm not sure I get the question 100%, but the best way for you to filter out keywords, I'm not sure what is a macro header file. But if you want to fit, if this is what you mean by keywords, let's say you mean like Rust keywords. So for example, you want to check, let's say a Rust keyword could be a use statement, right? You could use this, or let's say you want to use a return. actually it's meant to be a type. So let's do something like this. Let's xx input parse. Let's turbo fish that, and let's use token. So let's use again, right? So basically, yeah, right, you can use this expression, and what this basically does for you is first let me just question mark that it's outside of the closure. As you can see, this is giving us a use type, right? We are parsing a use type, but you can as well just write this out manually, like it's under this in token use, right? So you can do this, but the benefit of this is you don't have to remember the type name or the type path, right? You could just use this and it automatically assigns the type to it, right? So we're checking if that is a begin transaction statement, then we pass in the input and maybe just maybe if you're checking if it's a begin transaction statement, blah blah blah, you know what, so after we parse, let's remove this, remove that. So we first check if it's a transaction statement by checking the beginning. If it is, we parse that. Then we parse all the queries and statements that come afterwards. Then we check if it's a block, likely. So basically, after we parse the queries, we want to check if it ends with a return statement, and that is what this does. It checks, it picks into the token. Well, then if it's a return statement, it basically returns the type block with the expression, return expression, and also the statement. Then if it's a begin transaction statement, it does this, right? It returns a transaction. Otherwise, if it doesn't end with any of those, it just does this. So since we're checking this, we can actually just say we can revert this to say it's transaction statement, right? It's likely transaction statement, and we can return also to paste. So this could be commit, or this could be cancel. Yep. What could I be missing here? Please and that. Okay. Yep. So we check that. If it's transaction, we return the transaction ending. And let me show you the implementation of transaction ending. It's quite simple. What it does, it checks the first two tokens. So the ident, if it's an identifier, it checks if it's commit, right? If it's commit, then it returns a type commit. If it's cancel, it returns a type cancel. Otherwise, it returns an error because it has to be either. Then it returns transaction if the second token is transaction, right? So basically checking the next identifier. If it's not transaction, returning an error, blah blah blah. So that's what that does. So yeah, if neither of these matches, then we return a query chain. So that's the implementation when you go to query turbo now. So first get the query turbos or queries turbo, and we can match that. Let's just match into that queries turbo. What does query turbo return? Let's see. Okay, there's an inner, so yeah, I can do queries turbo inner. Let's just, instead of that, we do inner, and we can fill that. So this is where we do something a little bit different, right? I'm just gonna comment this out first, and let's return a to do. So this returns a chain. This returns block, and this returns transaction. So what do we want to do? If we get like a chain, what do we have in chain? We have the statements, and what else? Yeah, we have the statements. The block also should have a statement. Let's check that out. Block. Yeah, that also has a statement with other stuff. So here we get a statement, and we need, so well, I'm just gonna copy this first, so I'm gonna show you guys what I'm up to. Let's just cut that out. Yeah, paste that and comment that out. So for query chain, let's copy this also. Then we can refactor later. So for query chain, let's see, we have the generated code. Let's scroll up. Let's pass in the statement here. So change the statement. That gives us generated code, and let's say statement. So let me show you the implementation of this. Well, it goes over the statement, right? When you iterate over the statement, if it's a statement, we get the identifier and the expression, right? And as you can see, this is actually creating a let statement. So I created this let statement that you can generate using the let function. We're stringifying the identifier, and it has a method called equal to or associated function, and it binds that to the expression, right? Then if it's an expression, it just basically returns that. So why are we doing this? You can imagine that if you have a let's say let results or user equals let statement, like user equal to, this is how the query builder works anyway. Maybe user equal to OU, right? Within the next expressions, let's say you're having like a create statement, right? You might actually want to use this identifier, like you might want to use that variable itself, and under the hood, actually this will return a let statement. So it will return the type let statement, right? And when you automatically assign this to any field, the way I've built this from ground up is that it knows that it's going to interpret it. Let's say you say, oh yeah, something like this, and name is equal to, I don't know, user. Under the hood, it automatically knows that when it's generating the statement, it should generate something like like this, because this is how the database engine understands or interprets a parameter, right? So when you're passing a statement, it knows that if it's receiving the statement as a value, because a statement is it's a statement, right? It means you can assign it. So if you're going to be assigning a statement builder, then practically what you really want is the parameter name, right? And that's why the variable name here is also used within this place, the same. So that's why that is that way. So we're first generating the code so that you can, when you're writing the normal statement that I showed you here, like let's say this amount to transfer, for example, I could do something like amount to transfer could be within this, right? It still works, right? But actually under the hood, this is not an integer anymore. Can you see that it's a let statement? Let me remove this and show you. You see that this is a fraction, F64, right? But if you put it within this, it's actually not a fraction anymore, at least at compile time. It's a statement. When you run your code, the database engine can then understand that statement as a fraction, like 300. So this allows you ridiculous amount of flexibility. So you can use a variable from within and outside of the query. Like as you can see here, we're using amount to transfer from outside and it's a fraction. But when we use it within this, it still works. But now it interprets this as a statement. But when it's actually binding this, it's going to be understanding this as a parameter, right? It's going to be understanding this as a parameter with this. So I think I'm happy with that. So let's go back to where we were at with the generating query chain. So we generate the code, and from the statement we also want to do something else, right? We need to aggregate all these statements, all these query building statements, so that we can pass this to the query chain. Then the query chain does all the variable binding, and it implements some traits that allows you to run the query and select one of the results, right? So what we're doing here is, for the first one, well, we're generating the full path for chain and getting the statement or expression to chain. So if it's a statement, right, we want to change the identifier, because the identifier, as I showed you earlier on, let's say for example this is an identifier, right? When we chain it, it's able to get the result of this query on the right side, the entire let statement, right? So that's why we get the identifier. If it's an expression, we just get the old expression. And we can also actually just get the expression here and just use the expression. That's a legitimate way. So we just copy the expression, but this would suffice. So what we're doing is, if it's the first, we get the full path. Otherwise, subsequently, we just chain whatever statement or expression we find, right? And the resulting thing is here, well, we get the generated code, and we also get the query chain. So this now does complain. I see why it does. Okay, let's just put like to do here, and yep. Yes. See. Do we need to consume that? Let's check. Okay, we could just borrow that. So we can use that. Let's remove the inlay and yeah. So for the chain, we just get like the query chain. Then when we want to do for the block, right, we do something slightly different. And I'll just copy the implementation I already have. We'll refactor later on and deduplicate all the code. So when you have block, you want something a little bit different. So we'll still get the generated code, right? This pretty much the same logic as the first, but the query chain might be slightly different, and I'll show you. Actually, the query chain is also going to be the same, yeah, but the different part would be the conclusion. Because it's a block, it has to end with a return statement, and so this is the part that would be a little bit different. So let's go to block, paste that in, and we could essentially just copy all this old stuff and stick it right there. Yep. Maybe remove this line. So let's just fix things up. That should be block. And what else? If only as only return we get the return expression from this should have the return expression. Return expression is block. Yep, that should have it. Does it? Yep, it does. So with that, we are able to get the generated code, and we're able to conclude that. As you can see, this actually ends that with a return statement under the hood, and then uses a method which I've created called as block, and turns that into a block. And the reason I decided to do this is just for disambiguation, so you know you're using a query chain or a transaction a block. You can. So for example, when you're trying to assign something to a field in a query, you cannot assign a query chain, nor can you assign a transaction, because those are statements. They don't evaluate into a value that you can bind to another variable, right? But a block is actually an expression that should return something which can be assigned to a variable, and that's why I'm using this. And as you can see, I'm actually doing something here. So it's possible for you to have a single return state. So like if this is you could have like query turbo, and just return 5. That should be a legitimate way to write a query turbo or a block. You don't have to have other expression, and that's why I'm doing this. Yeah, so I'm checking if there are other statements or not. If there aren't other statements, we just want to return that, right? However, if there are other statements, we want to first like chain those, then we change the return expression and we convert that to a block, right? Then we pass this whole statement here. I could call this chain bound statements. So we get the generated code and we get the bound one. So let's do the same thing for transaction actually, which is going to be quite similar. I could basically copy everything here and make a few changes. Statement, let's change that. Statement should remain the same. We'll refactor all these parts, so don't panic. So let's see how we've implemented query transaction. So as you can see, we have the generated code, we have the statements, then the difference is we have a transaction ending, and let's get that. But we have the transaction ending, so we take that. Let's just copy it. From this part, we could replace that up to this line. So we're matching transaction ending and transaction dot transaction ending, right? So we want to know if it's commit or cancel, right? So if it's commit, it returns dot commit transaction. If it's cancel, it returns dot cancel, right? So what we do is we change the beginning. Well, this will always be there. Then we pass all the queries that we've changed, and then we pass the ending, and that just basically gives us the query transaction. And the beauty of this is now we can dynamically, we might have to do a little bit of tweak and stuff, but the ultimate goal or the idea is that now we'll be able to dynamically determine if this is a query chain, if it's a transaction, or if it's a block. So that is what I'm getting at here. So we're gonna do a little bit of change and test things out and see what we get. So as you can see, we have all these. I call it X, but what could I call this? I could call this queries or bound queries, and just return that. We will refactor all these because I know there are a bunch of repetitions. We'll dry them up. So we get this token stream, and because this is of prop macro original, right? We need to convert that. And we can just use the into to convert that. So with these, we should be able to use query turbo for more stuff. Can't find block in the yeah, okay, this I know where that is. We'll deal with that later. But for this, let's see actually if that does work, and maybe commit that first. Let's see. Okay, we have everything. Make query turbo flexible. Can create query chain block and transaction, as opposed to just query chain previously. Yep, let's push that. so okay, let's test this. I worry a bit that my ID might mess up, but I might have to restart. But let's see. Why don't we try block first? So let's just try to return 5 and see what we get. Okay, unknown. This could be due to my Rust analyzer not being properly reloaded. So just to be sure, I might have to restart my editor. I want to be 100% sure it's not due to my ID. So we'll see. Let's wait for this to reload a little bit. It's taking some time. So what we're gonna do here while that is loading is, first we need to abstract this into a logic, right, into a function. And one thing I'm actually contemplating on is I could maybe create a trait that implements generate code and generate query chain, right? Then implement the trait for like the 3 query types, like query chain, block, and transaction, right? So that way, once we get this chain, whatever type it is, we can just call dot generate query chain code on it, or dot generate I mean generated code here or the query chain. You get what I mean? So basically just abstract it a little bit so we reduce this boilerplate. All right, this seems to have loaded, right? Okay, now we are getting something. Let's check on this side. Do you guys notice something? This now returns block. So let's go down a little bit. Let's check. Let's remove this. Do you see? It now returns query chain without a return statement. So what happens if we have like a begin transaction? We can have this in caps, of course. Begin. Let's remove that. Then let's end that with commit. So we should get a transaction completion statement here. Unexpected token. Interesting. Let's see what happens if we do. Alright, so that doesn't work and we need to figure that out. But as you can see, block already works, so it doubles as block statement and also query chain. But we need to figure out transaction. So let's check for transaction query turbo. So first, it's likely a transaction statement. Begin transaction. To string, split white space, collective vector, join, single white space, to local. So if, but yeah, I believe we're not parsing anything. If it's a transaction statement, it should parse that, and the person is done this way. Checks the first ident. If it's not equal to this, what's the error? Unexpected token. If it's not this, it returns an error. Then it parses the second one. Checks if it's transaction, otherwise return an error. Okay. So what could I be missing here? Let me comment this out first and see. Because if it's a transaction, then it should just parse that. And we actually can just simplify this, because if there's a begin transaction statement anyway, we don't have to check. It should be a transaction, so we can just check that. Remove that. Remove all that junk. Remove this. So this, remove that also. Remove that. Remove that also. So it's transaction and parse the begin transaction, which I believe this should take care of. Then after that, parse all the query chain. Then check if it's a block that this works. If it's a transaction statement, parse the ending. Yeah, and this should work also. Pass the first and second identifier at the ending token. Then we have the transaction ending being parsed. So this all looks good to me. Let's maybe restart the IDE again and see. That should pass the transaction ID, ending. So what I'm probably gonna do in the meantime while we're waiting for this to load is because if I show you guys, I have this bunch of like macros I've created. So these are some derived macros. So my plan is to move this to a separate package. So we have query raw, we have query turbo, we have block, we have transaction, and I believe we have embed migration. So I'll move embed migrations into migrator macros, and I'll move all these to query macros. But for now, let's just that part already loaded, but let's see, does this load yet? No. Anyway, so as you can see, for query transaction we have some repetitions here, so we're regenerating the code here. We could call the function here, so let's do it already. Let generated code blah blah, because generate blah blah, yeah, that should work. Let's remove that, and for this statement we could do the same. Generate query chain. Yes. Generate bound query chain, and let's borrow that also. I need to make this function a constant or static stuff, but let's just do it that way first. And now we could borrow that. I'm gonna move all this to a trait later on, and probably should move all this to a different module, but let's leave it here first. We'll do all this refactoring later. So this here is generated code, and then also we need what did I call that? Query bound. Generated query bound. What's the name of the function? Okay, query chain. Yeah, just copy that, so we can remove all this code. We can remove all that code. Let's do the same thing anywhere else. We have so we can do the same thing here, and 18 okay, looks good. Do the same thing, yeah, basically from this line to 19, replace that and copy that. Let's do the same thing here until 19 also, replace that. Okay, where else do we need to do similar stuff? I believe that's all for now. Okay, so as you can see, this now works, guys. I figured that was from the closure. So now you see this generates a query transaction completion. So let's remove this and let's remove this. What happens? You get a query chain, right? Let's revert that change. What do you get? You get a transaction completion. what happens when you get a return, when you have a return, any expression. And mind you, you could even return one of these statements. You could do something like this. It's perfectly valid. But of course, it has to end with the colon. What do you get? You get a block. And that's perfect. So one thing I'm going to show you is transaction still works. So let's say we assign this. I mean, technically you can see this here on line 25 below. It returns a transaction completion, right? So that's cool. What if we check query block? What you're going to notice is this works here because we're able to assign it to a field. So this is the beauty of this. We're having a create statement. We are using this macro called object partial, which I also created. What object partial allows you to do is you are not only able to assign primitive Rust values or complex Rust values, you're also able to assign statements, parameters. I'm talking about the database statement, database parameters, and even block. As you can see, I'm only updating. So we have two types. We have object and object partial. Like if you're using object, you have to put all the fields, right? So as you can see, it's already complaining because some fields are missing. There are probably two fields here. What's wrong with my editor? It doesn't complain anymore because it expects both fields. But if I'm missing one of the fields, it's going to complain. And that's the case where you use object partial, typically when you're updating. And one thing you're going to notice is, so we can also update the ID field, right? But we shouldn't do that. What you're going to notice is, for the average trend, we're actually passing in a block. We're having a very complex series of statements here. We are selecting a value from a table. See how natural this feels. It doesn't even feel like you're writing Rust. Then we are summing that. We're using this function. This is not as you can see, this is a function that I've created, right? And it's taking this strength. As you can see, strength is actually a statement, but under the hood, when you're passing a statement as a parameter or as an argument of a function, it understands that it should take the variable name as a parameter. And I will show you the statement it generates soon. Then we're counting this, and we're even generating this complex mathematical expression. And mind you, even though we're using division, multiplication, math.ceil, it actually generates a statement under the hood. Like it generates, and I'm going to show you, as you can see below here, it sets the average strength into a block. It introduces the block syntax, open and closing bracket, right? So you can see that this actually generates a query statement under the hood. Let strength equals to select. Then it passes the variable name as this to this function. Then passes this strength also to this. And we have this. So you can see that these variables are actually generated as parameters under the hood, right? It generates them as parameters under the hood, right? And we have these 4 and 100. The reason we're having actual 4 and 100 not being bound is because we are converting that into a raw statement. So when you say to raw, basically everywhere you're supposed to have interpolation is going to put the raw values. And as you can see, the original stuff, I'm using fine-tune param, so it's not being randomized. So I created that function to not randomize this so that our test can be deterministic. It will get the same result every time. So as you can see, all those 400 and 100 are actually being parameterized here. So we have the parameter 2, then we have parameter 3, right? So that's the beauty of this. And I think we've been able to achieve the flexibility of making query turbo into different stuff. So here you can return 5 times 4 divided by 9, and it's still gonna work. It's generating a block, and you could use a transaction, and it understands that this is now a transaction. And when you don't put any of those things, it understands that, well, it's just a query chain. You just have series of queries, right? And that's the beauty of this implementation. So as you can see, maybe I'm gonna zoom out a little bit. We have these queries, right? Like I said earlier, we can take the third index, right? So this is gonna be the first, which is 0, second, which is 1, third, which is 2, and this is 3. And we can just take that and put 3, and you would notice that this actually returns a vector of account. If we want the first result, like I said earlier, we can just do first, and that is the type of balance. Then of course we need to remember to change that to 0, and we get option balance. So this is an extremely powerful way for you to use this that, as far as I am concerned, doesn't exist anywhere else today. So I'm quite excited. Yep, we are done with this for now. One thing I can see us is improving, of course. Let's take this all out first. We just need to clean things up. Let's clean things up. Blah blah blah. Remove that. What else? Remove that. Remove this. What else aren't we using? Remove the parentheses. Yeah, okay. Yeah, we're not using that. We're not using that. Actually not using this either. Let's just do that. Let's do something like that. Yeah, I'm really not using this, so I don't know. Let's just, we could remove that later on, but it feels unnecessary, so let's just remove it right away. Actually, let's take that off. Bam, bam, remove it. Where else? Remove that, because it's always true, so it's needless. So let's just clean up. So the next thing I would like to do is refactor things a little bit and fix some stuff up. So the first thing we could do, there are two things that come to mind. I'm looking to move this module into a separate package and move these two into a separate package also. So maybe we could do that next. Then afterwards, I'm gonna move these different query chain and stuff into different files, and then do the refactoring that I wanted to do. And this is probably okay, just passing this different function. In my opinion, I think it's okay. But one other stuff is, since we're sharing this part of the implementation with other parts, we could as well so this could be a method on transaction. So for example, I could do get transaction blah 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 and go to transaction and make an associated function. So that's probably what we're gonna do. But in the meantime, let's clear this up a little bit. It's taking too long. Okay, let's clear it up and let's create a new package and call that first. Let me check this. So we've got migrator, so we can create cargo new and call that call that migrator macro, right? Macros. Oh, do I have that already? No. Okay. We could also create queries macro or query builder macro. Query builder macro. Let's query macros. Those two are probably okay. Search. Okay. So let's come here. We would need to add them here. So migrator macros. We have query builder macros. Yep. Query macros. I can just call this query builder macros. That's fine. And query builder. I mean, prop macros technically. So let's add them here. Then we have. Oh no. Okay. Macros. Yep. So let's go to derive and we have migration. We can just copy that and let's bring that on the migrator macros. Paste that there. So we have migration here now. And it's not so much, it's just 163 lines, so it's probably okay to keep that in within a file. Then from there we've got this embed migration, I believe, which we can just copy. Cut there, actually just cut that away, and right here we can put this to the token stream. We'll come back to that. So we're missing token stream, and of course we need to import maybe that. What else do we need to import? We need to import migration. Let's remove this here already. Let's cut that out and oh, up there. Let's go up a little bit. So migration, generate embed migration. Models. Okay, take that and then token stream. Of course, I need to declare the package as a prop macro. I need to do the same here. Yep. We really don't have to turn out the doc test, but it's okay. So I'll do the same for query and query builder. Maybe just cut them actually. Anyway. Query builder. delete those two. Now we have this query. So we can just take from there, copy all that, and put that right here, stick it in. Yep. So we have a bunch of stuff we might have to import here. You know what, so we need scene, codes, prop2, and the query builder. Yep. And yep, take that. What else do we need? Saturday? I don't think so. We at least need migrator for this. Yep, we need migrator, and yeah, we don't need migrator anymore, I believe so. I will actually leave it in the meantime. I can see me using it. Then the derive macro. So Saturday is pretty standard stuff, but anyway, I just put that sticker in for a while. Yep, let's check these. Let's check this. Put the dependencies here. We probably don't need a migrator here. I can't. Yeah, we don't need it. Anyway, so I've got the dependencies here. Let's check. That checks out. Blah blah blah. What else? Let's check this. Models. Oh, I remember. I've got this function name. That gets interesting. I guess this could. Interesting. It's probably somewhere here. Get create name. I don't want to copy this around, obviously. So here we actually need this too, and of course I can create another module, another package, and call it proc macro YouTube or shared or something. Maybe I should, because I can see myself sharing more stuff. So let's go cargo new blah blah proc macro shared, or I could call it helpers, whatever, helpers share, whatever. So what I can do is take things like utils. I know, guys, we will figure it out. I could take something like this and stick it right here, and of course we have to declare this as a proc macro. And what do we need? Codes, proc macro create, okay. So we've got three stuff: proc macro true, and proc macro create, and codes. So I'm just gonna go here, 913 and codes, just take that off. Okay. And string is probably useful. Then declare as where's the helper? Okay, gotcha. Declare as a proc macro. No, I don't have to declare this as a proc macro actually. So let's just maybe comment this because it's just a helper, right? I'm actually looking at the possibility of having that within the query builder itself, but maybe that doesn't check out. Let's just do it here. And so public, and let's put it within, declare it as public workspace, and we're gonna call this proc macro helpers, and don't forget we need to do the same thing here. So we got migrator, macros, we've got query builder macros, then we've got migrator macros, creative macros, and also proc macros helpers. Yep. Okay. Yeah. So now what we can do is let's go to is this complete? Do we have everything we need here? How about here? One thing we don't have here is this function, so we'll have to import that by saying remove that. Though it's not everything. Okay. Query builder, not that, but the macros. Oh, actually no. Proc macro macros helpers. We're gonna improve the naming later on, but let's just make it work first. Oh, I'm actually not using that here. No, I'm not. Oh, okay. Oh, yeah, I'm using it here. So what we can do is change this to proc macro helpers. Yeah. Yep. What about here? Are we using that? Yep, we are. Get create name. Probably want to use that, yeah. Yep. So we're using it out there. Okay. So let's check. We have that there. One more thing we want to do is we have to respect those. Yeah. So we actually want to export query builder macros. Macros. I probably have to turn on the lights. query builder macros, then what else? Migrator macros. Migrator macros. I'll turn on the light. So we've got query builder macros and migrator macros, and we can come right here. As you can see, these were coming from. I'm also thinking if I should pull this from within the roots, and maybe I should, but this will not come from query builder macros, I believe. Same thing here, same thing there, same thing there, same thing there. Yeah. So we have transaction, query table, block, query raw, and this. And for that, embed migration should now come from migrator macros. Yep. Okay. That looks good to me. So there's one more thing we need to fix. I believe it's from for statements, for loop. We're using a macro rule here, and yeah, we're actually using block. So one thing we might want to do here is to import that into query builder and use it here. So because we depend on that, there are two things we could do, two ways we could handle these. For sure, we could move this into we could move that into the macro, and that's a legitimate way to do it. I'm actually not sure if we could export a macro rule from a procedural macro create, but I mean it's worth trying. Yeah, so let's let's see what we get. So this would be on a query builder macro. I'm not sure if this is legitimate way of doing this. Yeah, I'm not sure. So block. It's just gonna be I'm actually not sure. Well, we'll see. So why we re-export that? Okay, it's already let's go up there. I have to reload. Let's commit this first. have to restart my IDE to fully see my editor is messing up and acting up. Yep. So what do we have now? Let's go to the other side and let's see if this is being properly imported. Query builder macros. Yeah, and we have it here. Query builder macros. Here we do. Then we also have it here. Okay. Still loading. So we need to confirm if macro rules can actually be declared from within procedural macro package. If it can't be, then we would have to import query builder macros into query builder into the query builder and use the block macro right there. So the reason I'm also doing this is to prevent the dependency cycle, because if I import, so let's say the query builder, the block macro is within the surreal derive, right? And the surreal derive already depends. This is actually important. The surreal derive depends on the query builder, and if I try to import the surreal derive back into the query builder, then that is going to cause a dependency cycle, right? That's why I'm not doing it. And we might actually have a dependency cycle. I need to check that. However, one thing I need to confirm is that we're not using surreal derive here. Okay, we're not. That's helpers. Okay, in this case, let me check if we're actually using it, because if we're using it, then that's not gonna be possible for me to. Oh yeah, so we're using it, but we actually don't need to. Let's see. We're using it, but we don't have to. We could just use from the database engine straight away, which is a good news. So I just need to be sure that everything. Okay, so right now it's not being built. Let's check out VS Code. Probably there's a dependency cycle somewhere. I think I mentioned that, and it's, let's check query builder. Okay. Let's check this error from VS Code. Failed to load manifest this. Error inheriting from list. Blah blah. Proc macros helpers was not found in helpers. Okay, let's see why that wasn't found. Proc macros. Okay, it should be with an S. Yeah, I see. Okay, proc macro helpers. Yep. So let's see if it loads now. Does that actually reflect here? But it actually does exist now, doesn't it? Um, So, around macros dependencies. What's happening? Query builder macros. That should exist. Proc macros, helpers. Proc macros, helpers. But not found in workspace dependencies. But it is right here. Dependency. Am I missing something? This looks okay. That seems to work now. Okay, now we cannot export. Yeah, so that was what I wanted to confirm. We cannot export proc macros, which I guess is okay. So we can take that out. So what we would have to do, first import this. That looks good. Yep, import that, import this. So what I'm gonna have to do is because I wouldn't want to import the query builder into this package, otherwise I'm gonna have a dependency cycle, because I need to use if I import this into the query builder, do I need to use the query builder here? Let's confirm again. We're not using it there. Technically, no. Technically, at least for now, we don't have to. But how about in the future? How can we circumvent this dependency cycle issue? Because right now we can do without it, but okay. But for now, we can deal with that later on if that arises. But anyway, let's come here. So this now goes into proc macro. Do I even have that? Helpers. I can just export. Let me export it from here. It is. So I'll do pub use proc. Anyway, yeah, macros, to the comma. Yep, it's looking good. First disable and then yep, that does look good to me. What else? So we need to import this into query builder. Query builder macros. Let's try and keep it clean. And now we gotta do query builder macros. Yep. So the way to circumvent this is, okay, I can definitely import this into query builder, but we'll deal with that later. So what I can do is copy the macros. I'm having a rethink with this because we could actually create a function that just a function that calls this for loop. Let's see if that is gonna work. We could put it under query builder macros. So what if we create something like this and we call it first, let's just close everything else for a loop. So here we're using param, all good. So what if we take this as a whole and do this, rather than exporting that, we actually just, because you cannot export a macro row from like a procedural macro, but rather than exporting that, we just use it, and then we create something else. Let's call that for, right? And for that we just basically call a for loop. Isn't that possible? Shouldn't that be possible? I don't see why we couldn't do something like this. Worst case scenario, we create a function that actually uses this for loop. I'm gonna explore this approach. I'm gonna explore it. Let's wait for this to load. Yeah. So once we finish this, figure out this for loop, make sure everything runs, then I'm gonna update the test. I'll make sure you can use query turbo to generate like query chains, to generate a block, and also to generate a transaction. Oh, it's meant to be a macro. I can actually just write this as a procedural macro because it's just yeah, I think I'm just gonna write this as a procedural macro anyway. That's what I'm gonna do. I'll write this as a procedural macro, and this would be okay. Yeah, that's what I'm gonna do. Anyway, I will write this as a procedural macro. Let me see the example of the usage. Yeah, you can do all these. Could you even do an assignment within this? Did I check that? Okay, good. It's gonna be an expression here. So I just need to decide if I'm gonna make this into a okay. So let's see. My ID wouldn't load. Okay, there's an issue here. Was not found in workspace dependencies. It should be. Oh yeah, I see. But it is actually found. There seems to be a dependency cycle between what and what? Query builder and query builder macros. Yep, that was what I was talking about. Package migrator. C. I've been streaming for about 2 hours now, so I'll probably just take a break soon and finish the refactoring off screen. I don't know. Should I just finish it right now? Getting a little bit. So, virtual is the default into. We need to fix that. There's cyclic package dependency. Trinitary query builder depends on itself. Okay. Yeah. Query builder, yeah, which depends on this. Yep. That was exactly what I was talking about and trying to prevent. So this now depends on this, right? And also query builder macros now depends on this. So the way to fix that is to take this off and actually we can just use the database engine. We can do like workspace too. Oh, this is the root. Oh no. Oh no. I was gonna do it. Yeah. So. Yep. Do it there. So the place where we are depending on that should fix the dependency cycle thing. Yeah, that should fix the dependency cycle. And yeah, so I just need to decide how I want to handle this follow. Do I want to implement it as a procedural macro now, which I could. But first I'll just comment it out and maybe just put something placeholder. Yep. Transaction is defined multiple times. Really. There it is. Let's fix that. Really? Book macros, present replace. Of course. Yeah, I might have to import this again, but no, it should be present. Yeah, I might have to restart my ID. Let's see. see what we get. I'm glad with what we've achieved. So query turbo can now be used for like query chain, block, and transaction. And if you want a dedicated macro or function for transaction and block, they exist, right? And now I'm just restructuring the code a little bit, like modularizing things, and I think we are on a good track. So maybe I'm gonna finish this up outside of the stream, just finish up the refactoring. And what else do we have to do? Finish up the refactoring, and for the for loop I need to decide if I'm gonna write that as a procedural macro. Currently it's written as macro. I would like to leave it as a macro because it's easy, right? It's simple, it's declarative, and otherwise I could write it as a procedural macro also, that's fine, and I'll explore my options. But one thing I'm trying to avoid is importing any sort of macro into the query builder. That's one thing I've been trying to avoid, but we'll see. I think I am probably gonna chill. Okay. Oh yeah, the block loads now. We've got an error here. What's that? Okay, so okay, we can just take that off. What else? Yeah, the for loop. Yep. Yeah. Complain about that. How about I do pub use. Let's do pub create use query builder macros block. Yeah. This would be internal. Okay, the internal, was that internal tools? Okay, internal tools, and what's the complaint? Unexpected and all input expected return. Oh yeah, that's definitely. Oh yeah, this actually shouldn't be block, it should be query chain. Yep, so let's use query turbo. Small flexible. So the semantics have changed a little bit. Save that. Yep. So we fixed that, and it's good. We just have to decide. Let's disable. Okay, it's complaining about. I mean, query terrible. Yes. Create internal. Yeah, just use query terrible. Yeah. In that case, yep, this has to be lower case. Yeah, I actually don't think I will be supporting this kind of for loop anymore. Just for the sake of consistency. So I'll probably just comment this out for beats. I'll comment this out. Yeah, I see what this is complaining about, because within this we are using query turbo, and that expects Sorrel ORM, but we cannot use Sorrel ORM because that's the top level package name here. So with this new development, I think it makes sense to implement this as a procedural macro. So one thing I'm gonna explore, I don't know, maybe on stream or outside of stream, is see if I can create a function that calls this, and as a helper function that returns a token string, and just use that right here. So what I mean is this. So let's expand that. Okay. Okay, something like this. So this would be 4, and that would call for loop. So let's try to use the macro directly and see. So what we can do is maybe create another function just like we did with query transaction. Let's a query block, something like that. Let's see if we can make that work. Let's call that this. Supposed to be there. How do I usually use Okay, I guess I'll just re-implement the outing as a procedural macro. But before that, what I'm gonna do is I'm gonna refactor all this into separate modules. So we're gonna have query turbo. We're gonna have transaction, and we're also gonna have block. So first, let's just comment this all out. So, but I do share some stuff. So, let's see. And query chain. Turbo. Transaction. Maybe take block first. Return statement. I can leave this here, it's fine. No, probably need it in most of those places. Encouraging. Yeah, that's great. Question, Terry's statement. And this transaction. Yep. Encouraging. Creator. Ooh. So I need to export. I could just make everything public anyway since I'm not exporting them. Yep. Oh man, I think I'll probably just chill already. We need to maybe clean up the imports and everything a little bit, just do general cleanup. But one thing I'm looking to do now is to implement for loop as a procedural macro, because I'm really trying to avoid importing um, any kind of macro into the query builder package. So just because of that, I think I will just implement that as a procedural macro. And thanks you guys. Thanks to you guys for joining. I'm really excited, and I'll try to finish this before the night runs out and open a PR. So one thing we need to fix is for this for loop. I'm just gonna create this as a procedural macro. This will make our life so much easier. So all this basically from here, because if you notice we're using like query turbo within this, and I'm avoiding importing pro macro package into the query builder package, and just because of that I would have to implement this as a procedural macro. Yeah, I have to do that. Alternatively, I can create a separate package and call that whatever, and you get the gist. But I think I will actually, couldn't I do this? Let's check. Let's go here again. I totally forgot I could use something like quotes here. I'm calling this for loop. Can't I use quote? Oh, my editor is messed up. Okay. Ooh. So yeah, I was looking at doing something like this. And yep. Our code is also supposed to return a token stream. Yeah, I'll just implement this as a procedural macro. I think that's the way to go. So what I'm gonna do is yeah, I'm gonna have like a for loop, and for the for loop we're gonna have for loop. We have the param. We don't have. I think it's actually better that I implement it as a procedural macro, because I can imagine this becoming more complex in the future, by the database engine. So it's better that I just implement this already as a procedural macro, and it becomes more complex in the future. It's a lot easier, in my opinion, to modify procedural macros and modify it for your future use case. So we're gonna want iteration parameter param, and that's an ident. Then it's just for in. There's no for of, so there's no need to create like for type in or off. So I'll just leave it at that. What else? Iterable, that's an expression. Body is a block. Interestingly, body is just like let's include that. Alright, so it's actually no a query turbo. Let's see, query chain. Because I guess you shouldn't be able to return from it. So input query chain. Yep. I think we can just do something simple. Let's implement thank you. So we're gonna take first the param, then we take the in, and then we take the iterable. Yep, so that's an expression. Then the body, which is gonna be a query chain. But this is comma separated, punctuated. Actually, let's see. I think I did something here. I probably need to refactor this also. What do you think? Because we have about 370 lines, but a lot of it is actually just a bunch of text. Oh no? Let's see. Yeah, it's mostly just about 250 lines. I think that's okay in a file. But I can definitely refactor that a little bit also, just to keep it clean. Let's see, I'm using this. Anyway, so just like we've got it being bracketed. Yeah. And actually, no, braced. So we braced it up, and so I need to brace this also. What traits am I missing? Oh, I see. I see. Yep. I really don't need this because it should infer from this. So we parse the param. Okay. Sorry. Then we parse the in, and then we parse the iterable, which is supposed to be an expression, and not this. This should come. I'm not sure if it should actually end in. I'm not sure if it should end with semicolon. Let's see how we're currently doing that. Yeah, I should. Because it's an expression, right? Yep. So we press that. We also have to decide if we want to do the same thing here. So then it's gonna be eta content there. But this is parenthesized, right? So parenthesized eta content. So I guess we need to decide that if we want in which case then this would have to be eta content and in eta content, and then we pass the variable and step yep, you get the input again. It's the body the iteration parameter and the start of for yeah. So this is like the general idea and for loop actually I guess we can take that out, parse whatever is really need, and this gives us the for loop which we can then use. It gives us a query chain. I'm actually thinking this should just return a token string just like we're doing with others, right? Query block, yep. Token string. And this could okay. Let's fix it up a little bit. Convert that back. But so we'll get everything out. Get the generated code. From the body. No. It's not a block. So basically we want something like this. Statement for so param should be iterable param in iterable, then block be guess that's iterable and actually done it. Oh shit. Okay. So within this block I can basically just maybe not that. Take that away. Yep, I can do something like that. Import codes. So take the query chain within the block and let's see block. Yep. Query chain parenthesized. I need to create another method because sometimes we want to parenthesize query chain without No, that's why you have to be careful using this stuff. Can mess you up. Could mess you up big time if you're not careful. Um, yeah, so I got a statement. I actually don't need that. I got that. For loop. Ooh. Yep. For this for loop, the good news is we can probably just move a bunch of these and move that out, maybe just delete it, or I could actually You just keep it here first. Test. I'm going to do this, but actually I'll comment this here and comment this out. Just put a placeholder. You know what? I'll just comment out what's inside of it. Or yeah, like that. Like that. Can't export anymore. So let's take that. What else? Let's take this all macro implementation. Let me test. No. So you know that's actually a function. This is macro. Let's put it here. Let's comment it out first. Comment that out. Oh, did I delete the? No, I didn't. Perhaps I could even just just do it here. Super. Oh yeah, I'm using this block macro here now. And probably should be query turbo. Okay. I don't want to do that part manually, so I actually have to move the whole thing. Yep. Since we're able to, now we should be able to import. First, I'll have to comment that out. Should be able to import. Yeah, import that in, and then from the other side we would have to remove this, remove that from there, and let's make sure we're not importing any query turbo. So I think we're pretty good where we're at now, so I would say oh, my stuff is freezing. Oh shit. Alright guys, I love you. I think this is a good place to start. I'll take some rest and I'll try to continue from there. I might come back online or not, depending on the whatever. But I would like to take some break now, stretch a little bit, get some fresh air, and maybe see you guys again later today, or I might finish this off stream because there's not a lot to be done here. We've already implemented the for loop in procedural macros format. Previously, it was implemented as a macro rule, and we're doing that for two reasons. I'm trying to avoid dependency cycle. First, I don't want to import any kind of like macro, my self-implemented macro into the query builder module or package rather. And the second reason is because it's just more flexible, and in the future I am suspecting that the database engine, sorry DB in this case, might introduce some more complex implementation of the for loop. Probably maybe they could allow enumeration, maybe they could allow, I don't know, anything. Enumeration is just one of those things. And for now, I'm not sure even if you could iterate over like an object. So maybe they're gonna allow different kind of for off and stuff. And I think this is just more amenable for like amenable to changes and stuff like that. So I'm gonna clean up the implementation, update the test for the for loop. Those are the things left. Actually test that the for loop does work. And there is one consideration. Maybe I'll do this optionally. Should I allow you to, let me show you what I mean. So you could write a for loop right now. If you look at this example, you see we could, when we're writing the for loop, obviously we have the top level parentheses, but when you're writing the iterable part of it, naming something, right? Would you like that we leave this parentheses here, or we do this? Which would you prefer? Would you prefer this, or maybe we allow both, right? So I probably could support both. I don't know. Input peak token. Let's see if this is yep, this is not gonna fly. Anyway, I will look into that. I probably might have to pass this as parse it as let's see. Yeah, I'm gonna have to do this, and maybe do like if and we just parse it out. And then actually else otherwise Otherwise, I'm just gonna. I could do something like this, right? And actually, I'm looking like within like query turbo. If you have like query turbo, do we have text file? Maybe I could allow you to just write something like for for param in, let's say you could have a vector, for example, m1 m2. I'm actually allow this for you, then just write this and you could have it nested. This is something I can actually support. Then you do something like this, and you could even have another for loop within this. Yeah, I can support something like this, since for the like almost every time you want to write for loop, you'll probably be writing it within this. Alternatively, you'll still be able to use the for loop macro. So I'll support both, actually, thinking of it. The for loop. Yeah, anyway, I'm excited, and yeah, I'm actually excited, considering I could also share the follow-up implementation. Anyway, guys, I will see you again. I need to go now. I've been saying I need to go for a while. I'll see you again. I love you guys. I am gonna try to stream again. Maybe I'll come back online after taking a rest, but I'd like to finish this implementation tonight. See you guys. Love you, and have a wonderful and awesome one. Yep. Cold breather. Breathe it.